In this question, benzene and toluene form ideal solution over the entire range of composition. The vapor pressure of pure benzene and toluene at 300 Kelvin are 50.71 mm of Hg and 32.06 mm of Hg respectively. Calculate the mole fraction of benzene in vapor phase if 80 gram of benzene is mixed with 100 gram of toluene. So in this question, it is given that the vapor pressure of pure benzene is equal to 50.71 mm and the vapor pressure of pure toluene is 32.06 mm. This is the structure and the formula of a benzene and toluene which we use later. Now after that, in the question, mass of benzene is given as 80 gram and mass of toluene is 100 gram. So we have to find the mole fraction of the benzene in vapor phase. This we have to find in vapor phase. We just create some idea how to solve this question. So to solve this question, what we do, we have to use the Dalton's law, and Dalton's law is pressure of benzene of a mixture is equal to total pressure into the mole fraction of benzene. So in this question, we can use this relation, but here we have to find the total pressure. Pressure of benzene is also not given. This is the pressure for solution and this is the pressure for pure form. So we have to first find the PV and P total, and then after that we substitute, we can find the value of YB. So if we have to find the PV, we can use the Rolle's law. PV is equal to P naught B into XB. So now again here P naught B is given, but mole fraction is not given. So now we have to first find the mole fraction of benzene is equal to mole of benzene by mole of benzene plus mole of toluene. So here mole of benzene we can find because mass is given, and molar mass we can find, we know the formula. Same way mass of toluene is given and the molar mass we can find it. So if we find the mole of B, then we can find of PV. So this PV we can substitute it here. So we get the value of PV. Similarly, we have to find the total pressure. So total pressure is equal to pressure due to the benzene plus pressure due to the toluene. So now the same step we have to follow to find the pressure for toluene. So PT is equal to P naught T into mole fraction of T. So mole fraction, if we know the mole fraction of B, so mole fraction of T is equal to 1 minus mole fraction of B. So we have to follow this question in some steps. So this is our first step. This is the formula. So this is the first step. Second is finding the value of PB. Then third is mole fraction. Fourth is total pressure. And after that, again we have to find the PT. So now we can solve this question. So let's start to solve the question. We have already the idea how to start the question. Apply Rolle's law. P is equal to P naught into mole fraction. So for benzene, PV is equal to P naught B into XB. So XB is equal to mole of benzene divided by mole of benzene plus mole of toluene. So now separately we find the mole of benzene and mole of toluene. So NB, mole of benzene, is equal to mass of benzene by molar mass of benzene. So mass of benzene is given 80 and molar mass will also be 80. So NB is equal to 1 mole. So we got the mole of benzene. Similarly, we can find the mole of toluene. So here the mass is 100 gram and its molar mass is 94. So Nt is equal to 1.06. So we got the mole of toluene. Now we substitute it here. Xp is equal to 1 divided by 1 plus 1.06. So 1 by 2.06. So mole fraction of benzene is equal to 0.485. So we got the mole fraction of benzene. Similarly, mole fraction of toluene is 1 minus Xp. It's equal to 0.514. So now we have mole fraction of benzene and mole fraction of toluene. So we can substitute these relations here and find the value of Pt and Pb, applying the Rolle's law. So here for benzene, we know that Pb is equal to P naught B into Xb. So here Pb is equal to P naught B is equal to 50.71 and the mole fraction we just got 0.485. So Pb is equal to 24.594. So approximately it can be 24.6 mm of Hg. We got the Pb. Similarly, we can find the value of Pt. Pt is equal to P naught T into Xt. So if we substitute it here, Pt is equal to 32.06 into 0.514. So P toluene is equal to 16.478 mm. Round it off 16.48 mm. So now we have the pressure of benzene and pressure of toluene. So total pressure is equal to Pv plus Pt. Total pressure is 24.6 plus 16.48. So P total 41.08 mm. So we have total pressure. So now we can apply these two values in our this formula. Pv we already got, P total we got. So Yb is equal to here we can apply the Dalton's law, and based on that P benzene is equal to P total into mole fraction of benzene. So mole fraction of benzene is equal to Pb by P total. Pb is equal to 24.6 and P total is 41.08. So mole fraction of benzene is equal to 0.6. So this is the answer of this question. If we have to find the mole fraction of toluene, we have to subtract with 1 and we get 0.4.